Okay, the question at hand is how do we see things? We've got this nice scene with a person in a tree, but the question is how do we see? Well, to really break it down, we'll notice in the corner that there's the sun, the source of light, and it's going to emit its different rays of electromagnetic radiation. Primarily the ones that we can pick up with our eyes is what we care about. So we're going to be thinking about like white light, red, green, and blue, shining down all over the place. Now, if the question is how do we see this tree, what we need to think about is how does the light that hits the tree reflect? So notice all these little green rays of light going off in a bunch of directions. That's because the light that hits the tree of the red, green, and blue, the green is reflected in a bunch of different directions. Now what we care about is the light that's reflected into your eyes. Now notice there would be a couple rays that would be able to make it into your eyes. The rest of them, they just go off and shine wherever else. The question again though is how does that allow us to see? Well, all we can do is receive light into our eyes, and then our eyes and our brain does it from there. To imagine what we see then is essentially just tracing back these rays that we're able to make it into our eyes. If we look at these rays, notice that the geometry of how they've reached us converge at this one point. So together, our eye and our brain recreate this point of the tree that would be at this place where I just drew that dot. Now let's imagine a slightly different scenario. Let's say that there's a giant puddle or maybe some kind of small pond here between you and this tree. Now remember, the idea is that the eye can only receive light. Now we're going to look at how this little puddle of water could affect the image of this tree. So remember, the sun shines light, it hits the tree, the green light is reflected in all sorts of directions. Particularly, light rays that hit this water are going to be reflected so that there's a possibility that they end up in your eye. Now that first ray that I drew ended up hitting you to where you see it. This one, it missed you, no big deal. But let's look at another ray that maybe ends up in your eye also. Stressing this idea again, your eye can only receive light into it. So your eye and your brain together are going to construct a location based on where the light came from for this point of the tree to exist. So if we imagine tracing these rays back to where they would have seemed to come from, and then look at our drawing here and again ask this question, what are we going to see? Our eye, along with our brain, would think that this point of the tree came from here. And so our brain constructs an image of the tree that would appear like this to us. Now you're thinking, well, hold on, I'm not going to see an upside down tree. Think about looking at scenery in the distance when you see it reflected in water. It looks like it's upside down, just like this image of a real scene. The tree isn't really there, it's not really upside down under the ground, it's in our brains. Our brains are constructing this image based on the light that enters our eyes. Take a look at this more complex picture. You can really see the details of how this image appears to have come from behind the mirror. And again here in this real image, how the vase seems to exist behind the mirror. It really doesn't. It's just all about understanding how rays of light are affected by mirrors, or maybe even other objects, but how those rays of light are affected. And since all we can do is receive light, our brain constructs images based on where that light came from. And that's how we see.